Good day, ladies and gentlemen. I hope you are still doing good as you are approaching your trial examination. Do you get me? So, here today we'll be doing question 3. I think it is a high order question, this one, but on my side it is a low order question. Do you get me? Maybe to your student it can be a high order question, but don't worry. After doing it with me, it will be a low order question, even on you. Do you get me? They say I I can't really pronounce this word, but a sightseeing here point is built by placing concrete cylinders with a height of what? Of 0,2 on top of one another. The height of this concrete is 0,2. Each concrete, this one is what? Is 0,2 here. We have 0,2 here. We also have 0,2 here. Do you get me? And then, yeah, the radius of each consecutive cylinder is 4,5 of the previous cylinder. The radius of the cylinder on bottom is 15 meters. Okay, since this radius of this cylinder here is 15, okay, let me indicate that. I'll say r is what? Is 15. It means this r of this cylinder here, it will be what? Since it will be, our r will be what? 15 multiplied by what? By 4 all over 5, which will give us what? 12. You get me? The third one, our r will be what? 12 multiplied by what? By 4 all over 5. Let me patch a calculator and see what are we going to get. 12 multiplied by what? 4 over 5, which will get 48 all over what? 48 all over 5. Do you get me? So here we go. Why am I doing this? I'm doing this because they say the radius of each consecutive cylinder is 4 over 5 of the previous cylinder. If we want to find the radius of this one, we must multiply the previous radius with what? With 4 over 5. That's why I'm doing this. Okay, so let's do what? Let's go and answer our question. They say John is standing on top of the 17th cylinder, on cylinder number 17. Calculate John's height above the ground. Hey, John, why are you going to stand there? Yo, look now, they want us to calculate your height. You see. So let's do this. Gonna say what? John's height. Since they say each height of the cylinder from here to here, we have what? 0,2. And from here to here, we have what? 0,2. And from here to here, we have 0,2. Because they say each height is 0,2. When I say what? 17. Because John is on cylinder number 17, we multiply by this height of what? Of 0,2. Do you get me? And then we're gonna get John's height. Do you understand? John, next time don't stand on cylinder number 17, please. Yeah. Here we have 3,4. What? They gave us there in meters or what? Let me check. It is on meters. And then we're gonna indicate 17,4 what? Meters. Do you get me? They say calculate the volume of cylinder number 17. Do you get me? And let me answer it here. What do we need when we need what? Okay, I'm gonna say 3.2. To calculate the volume, what do we need? They say a volume of a cylinder is pi r squared h. Do you get me? This h stands for height, and we know that what? The height is always 0,2, and then r is your radius, but we don't know the radius of cylinder number 17. So we have to calculate the radius of cylinder number 17 first. How are we going to get the radius of cylinder number 17? We're gonna use this radius here. We have 15, 12, and what? 48 all over 5. We're gonna write here, say 15. Here we have 12. Here we have what? 48 all over 5. Do you get me? And then it is still continuous. This what? This is a pattern. Do you get me? So we don't know whether our pattern is a arithmetic quadratic or geometric. Do you get me? So let's first check whether it's but I think it is what is a quadratic. Let's first check the quadratic. We're gonna say r is equal to what? Term number 2 all over what? Term number 1. Do you get me? And then it is also equal to what? Term number 3 all over what? Term number 2. If we find that the answer of term number 2 all over term number 1 is not the same with term number 3 all over term number 2, we are going to, it means that it is not a geometric. We are going to try maybe arithmetic, and then if we don't find the common difference, we're going to try a quadratic. Do you get me? So here our term number 2 is what? Is 12 all over what? All over 15. And then here term number 3 is 48 all over 5 divided by what? Divide by 12. Let's punch our calculators. Make sure you have a calculator. Do you get me? So here we go. We're gonna have what? Our r, our first r. When we say 12 all over what? All over 15, it is 4 over 5. Do you get me? It's 4 all over 5. And the other one is what? 48 all over what? All over 5 divided by 12. We get 4 over 5. You get 4 over 5. It means that the pattern of our radius, it form a what? It form a quadratic. So since we need the radius of what? Of cylinder number 17, we're gonna say what? We're gonna make our Tn is equals to Arn minus 1. Do you get me? What's your A? A stands for your first term in the pattern. It is 15. What's your R? Our R is 4 all over 5. Do you get me? What's our N? Our N, we need 17 because we need the radius of cylinder number 17 minus 1. Do you get me? So let's punch our calculators here. On a 15, 4 all over 5, and then 17 minus 1. Do you get me? And then here we get what? I will round it to 2 decimal place. I get what? 0.42. Do you get me? Let me see whether what are the units of that radius. Okay, it is in meters. Ne? I'm gonna say meters. We are not done. Now we need the what? The volume. Since we have the radius, we're gonna say V equals to what? Pi r squared h. Do you get me? And then here we're gonna have our pi. What's our r? Our radius squared is 0.42 squared. Our height is always the same, 0.2. Because all the cylinders have the same height. Let's punch our calculator pi, and then our r is 0.42, and then squared multiplied by 0.2. Here we get that our volume is what? Is 0.11 meters cube, because here it is 0.2 meters. Do you get me? And then here is 0.42. It is all meters. Since we're going to square it, it will be what? Our meters, it will be meter squared, and then squared multiplied by this one, you'll get cube. But we know that the volume is always in cubic, the units of volume. So let's go to the 3.3, number 3.3. They say calculate, yes, 3.3, calculate the volume of the concrete that will be used to fill the 17th cylinder. They want the volume of concrete that will be used to fill the what? The 17th cylinder. What are we going to do? Since, okay, maybe let me give you a practical example for this one. The practical example, maybe now, our first cylinder, it filled with the volume of what? Our volume here is 20, and then our second cylinder, the volume of the second cylinder, it will be what? Maybe it is 40, and then the volume of what? Of our third cylinder. This is an example. It's an example. And then here the volume of our third cylinder is what? Maybe it is 8. Do you get me? So they want us to do what? To calculate the what? The volume of the, okay, yeah, to calculate of the 17. Maybe here they want us to calculate the volume of the concrete that will be used to fill these 3 cylinders. What are we going to do? We're going to add this volume and this one and this one. Do you get me? This was an example, or when it is not based on our question on 3.3. I'm just giving you a practical example so that you can understand. You see. So here, what are we going to do now? we are going to do what? To make a pattern with our volume. Do you get me? So that you can understand, let's make a pattern with our volume. Do you get me? Let's calculate the volume. Here is 3.3. Let me use the black pen. 3.3. Okay. The volume, our volume number one, we have what? Let's substitute. Okay, it will be our T1 as pi r squared what? H. And then you're gonna have what? Pi here. Our r is what? It is 15 squared multiplied by what? Our h is 0.2. The volume of the first cylinder of the or the first base. Okay, pi. Our r is 15 squared multiplied by what? Our h is 0.2. Here we have what? 45 pi. 45 what? 45 pi. And then our term number 2 will have what? Our pi is what? Is our pi. And then the radius was what? Was 12 squared multiplied by h. H is 0.2. The radius of the second cylinder. And then we're gonna put 12 here. Gonna put 12 where we have what? 144. We have 144 all over 5 pi. Let's go and check the radius of the third cylinder. It is 48 all over 5. 48 all over 5. Term number 3. Term number 3 is what? Pi. Our r is what? 48 all over 5 squared multiplied by 0.2. Do you get me? I hope I'm clear. 48 all over what? All over 5. Then here we get what we get. Okay, it is 57.9 what? 91. Do you get me? Yeah, it is in comma. Yeah, comma something decimal. I mean. Don't mind my English. Here we are not learning English. We are learning mathematics. And then let's find our r here. Our r is what? T2 all over what? All over T1. Our T2 all over T1, it must be equal with what? With T3 all over what? All over T2. Do you get me? So here our T2 will be what? 144 pi all over 5 divide by, let me write here, divide by 45 pi. Do you get me? And then here T3 will be what? 57.91. Since I've rounded in, divide by 144 all over 5 pi. Do you get me? So let's see whether they are equal or not. If they are not equal, we're gonna try another pattern. Do you get me? We're gonna try to check whether it's an arithmetic or not. I hope you all understand. Okay, 144 over 5, and then we're gonna say what? Pi. Find that here on this one. I started with this one. Find that our pi is 16 all over 25. And then let me punch this one in the calculator. Yeah, it is also 16 all over what? All over 25. Do you get me? So now, since we have our what? We have our r for volume. This r is for volume. R for volume. And then a radius, yeah, a ratio, common ratio. This is the common ratio. Do you get me? It's a common ratio. We're calculating our common ratio, as we know that common ratio is T2 all over T1 or T3 all over what? Do you see a common ratio? Maybe someone will be confused since I'm using R for radius and R for common ratio, but I've indicated because I say T2 all over T1. That's why it's a common ratio. Do you get me? So let's say I'm gonna say Sn is equals to A 1 minus R to the power n all over 1 minus R. Do you get me? Our first term on this volume is what? 45 pi. We're gonna come here and write what? 45 pi. Do you get me? And then say 1 minus, what's our R? Our R is 16 all over what? 25. The power, what's our n? Is 17, because they told you here, they told you that do what? Calculate the volume of the concrete that will use to fill the first 17 cylinder. Do you get me? Then it's 17, and then I'm gonna close this bracket and then say 1 minus what? 16 all over 25, your common ratio. Okay, when we punch a calculator, we're gonna say what? 5. Let me punch a calculator for 5 pi. 1 minus, and then we're gonna say 16 all over 25 to the power what? To the power 17. Close 1 minus 16 all over 25. You get me? We get that our answer is what? Is 392 comma what? Comma 5. You get me? Since I was rounding to 2 decimal place from my previous, now when I round to 2 decimal place, because it is 392,499. When rounded to 2 decimal place, this 9 will it will be 10, then 10 you're gonna add 1 here to be 5. That's why it is like this. And then you're gonna say what meter? It is meters cube because we were using a volume. Let me check. Yeah, I think they say calculate the volume. Yeah. So guys, yeah, please don't forget to subscribe. Yeah, don't forget to subscribe. Yeah, I will continue posting more videos or uploading more videos. So if you have a problem, just click on the comment section and comment, because the comment section is on for you to comment. Yeah, or text this number 0715520 I will do your question. You get me? Thank you. Have a great day. Next time I will tell John not to stand on what? On the 17th cylinder. Do you get me? Yeah, it will be simple. Thank you.